We are the solar team from Green Campus Enterprise. What Green Campus Enterprise does is we annually measure the carbon footprint of Michigan Tech, and then we proceed to design and implement projects to improve the sustainability of the campus. For our project, we were looking into the feasibility of installing solar panels onto the ERC. This includes doing cost analysis and system sizing.
For this project, we have used Solar Pathfinder, which is shown on the right. This device shows us the objects that shade the area and how much shade they produce. We have done this measurement through all sides of the Earth. We have compiled all those measurements, as can be seen, and we can see that the south side is the best between all, which has less shaded areas.
With that, we did shadow estimates on each side of the building. The green shows that you can put solar panels there and there is no shading there. The yellow shows that there is shading at some points of the day or some points of the year. And then the red shows that you are fully shaded and you cannot put solar panels there. With that, we did the feasibility of how many solar panels we can fit on each side in the green area. We can fit 337 panels on the east and the west side because they are perfectly symmetrical, 270 panels on the south side, and then 153 panels on the roof. With this, we have about 1,100 panels that would be covering the ERC.
Using all those numbers, and we have calculated the produced energy from the three sides, which are the south side, west side, and east side.
With that, we did the amount of kilowatt hours that each side would be generating as long as the roof throughout an entire year. You cannot just take one number and then multiply that by 365. We had to go day by day and month by month because each day you have a different amount of shading and positioning of the sun. We have a lot of variables in our project that we were dealing with, including sun hours, energy price, panel price, energy price increasing each year, and then the maintenance per panel. The assumptions that we did, we increased by 20% and decreased them by 20% to see how they affected the overall cost of our project. The sun hours per day and energy price were the top two. Our energy price right now at Michigan Tech, we are paying about 7 cents for a kilowatt. So that was one of the leading causes and the cost for this project.
We have used all those measurements to do the cost analysis, and as can be seen, the revenue is calculated using the energy produced, degradation factor, and also the price of kilowatt that Michigan Tech pays for. Also, we calculate the profit, as can be seen, using the maintenance, the revenue that we already calculated, and the prices of the panels. The prices of panels include the installation cost, which is modules, inverters, soft costs, and hardware.
With that, we took the revenue and looked at it over a 25-year period to see which sides would pay back. The roof pays back in about 20 years. The west and the east sides will never pay back over their lifetimes, and then the south pays back on the 25th year.
Then we have calculated the energy versus consumption. As can be seen, the overall production versus consumption is about 26%. The overall consumption is not satisfied, which leads us to the question of, do we really need batteries for this project? We have compiled the numbers as can be seen on the right, which shows the energy produced by all sides. And the best month is July, which is producing about 1,600 kilowatt. And our daily energy consumption is about 4,000 kilowatts, which means that the production is a lot less than the consumption, which means that energy storage is not needed for our project. In conclusion, consumption versus production, if we cover the whole ERC with solar panels, including the roof, we are never going to be able to produce the amount that the ERC is consuming. And looking at the payback, since we are not generating we're not generating what the ERC is consuming. If we cover the whole ERC with solar panels, we focused on the south side and the roof only. And with that, we can see that the south side and the roof is paying back in about 20 to 25 years, better than not ever being paid by all sides. Thank you.